In this video, we're going to look at the limit as x approaches 2 of 2x squared minus 8 all over x minus 2. In practice, to find this, all we do is we say, well, that's the limit as x approaches 2 of 2 times x squared minus 4 over x minus 2, which is the limit as x approaches 2 of 2 times x minus 2 times x plus 2 all over x minus 2. My x minus 2's cancel, and so this is equal to 8, because I can just plug the x equal 2 in. And so we claim that the limit as x approaches 2 of 2x squared minus 8 over x minus 2 is 8. And in practice, that's how we solve this problem. However, that's not a proof. So I want to show you how to actually prove that this limit is 8. To do that, we are going to first have to remember the definition of a limit. And to prove this, we need the technical definition that involves epsilons and deltas. So the definition of a limit says that the limit as x approaches a of f of x is equal to L if for all epsilon greater than 0, so every single number bigger than 0, there is some delta, a different delta for each number probably, greater than 0, such that whenever 0 is less than the absolute value of x minus a, which is less than delta, another way to say that is when x is not equal to a, but x is within delta of a. So x is close to a within delta and not equal to a. Then the absolute value of f of x minus L has to be less than epsilon. So what it's saying is whenever x is within delta of a, whenever x is close to a, f of x is within epsilon of L. F of x is close to L. The way to think about this is if I'm looking at a graph, in this case, it's a linear graph with a hole in it. But if I'm looking at a graph of a function and I'm saying, I want to know what the limit is as we get close to a, what I'm really saying is if I want to approximate the value of the function within some epsilon, so I'm within epsilon of L, then there has to be some x values that as long as I stay within that window, my outputs, my f of x, is within the epsilon window of L. So as long as I'm staying within the within delta of A, then the output is staying within epsilon of L. And this has to work. There has to be such a delta for every single epsilon. So to prove this, what we need to start with is let's define some things to make our life easier. So we are going to define f of x to be equal to 2x squared minus 8 over x minus 2. And note that if x is not equal to 2, then f of x is equal to 2 times x plus 2. And that's just by factoring the numerator and the denominator and canceling the x minus 2 out. So if x is not equal to 2, then we can simplify this to just 2 times the quantity x plus 2. Now, we need to be able to prove something for every single epsilon greater than 0. So we will let epsilon be any number such that epsilon is greater than 0. And now we're going to do some little side work. So this is not part of the proof. It's just us thinking. So over here on the side, we're going to add some thinking. So for our first bit of thinking, let's look at epsilon being equal to 0.1. What would happen if epsilon was 0.1? Well, then we would need some kind of a delta. So we want a delta such that if 0 is less than the absolute value of x minus 2, so I'm within delta of 2. This implies that the absolute value of f of x minus 8 is less than epsilon. So if I'm within delta of 2, if x is within delta of 2, then f of x is within epsilon of 8. But my epsilon, in this case, I'm assuming is 0.1. And so by replacing f of x with 2 times x plus 2, which I can do since we are not allowing x to be equal to 2, I get that this is 2 times x minus 2, sorry, x plus 2, minus 8 is less than 0.1. That's what I want to be true. But doing a little simplification, that comes out to being the same as 2x plus 4 minus 8, or 2x minus 4, that absolute value being less than 0.1. And if I factor out a 2, I can write this as 2 times x minus 2 is less than 0.1. Dividing both sides by 2, I get that the absolute value of x minus 2 has to be less than 0.1 divided by 2, which is just 0.05. Well, this x minus 2 and this x minus 2 are the same thing. So what I'm saying is if delta is less than 0.05, that will work. Because whenever x minus 2 is less than 0.05, then my f of x minus 8 is less than 0.1. So that's kind of the idea of how we build this, but there's nothing that says that we have to put in a number. So let's redo this. This time, just using my epsilon. So we're using epsilon, and I'm saying 0 is less than absolute value of x minus 2, which is less than delta, implies that f of x minus 8 is less than epsilon. So, solving this f of x minus 8, we get absolute value of 2 times x plus 2 minus 8 is less than epsilon. Or 2x minus 4, the absolute value, is less than epsilon. Or 2 times the absolute value of x minus 2 is less than epsilon. Or we need x minus 2 absolute value to be less than epsilon over 2. So our delta is going to be epsilon over 2. So now we have delta, we think should be epsilon over 2. So now we are ready to prove the limit. So we let delta equal epsilon over 2. Now, if we're letting delta equal epsilon over 2, then we have whenever zero is less than the absolute value of x minus 2, which is less than delta, or epsilon over 2, then, well, the 0 less than absolute value of x minus 2, this first less than, that is just telling us that x isn't equal to 2. So then I can just rewrite this as absolute value of x minus 2 is less than epsilon over 2. And I've got all of the information, assuming that x is not equal to 2. Now I multiply both sides of that by 2, and I get then 2 times the absolute value of x minus 2 is less than epsilon. Multiply the 2 through, and I get that the absolute value of 2x minus 4 is less than epsilon. And now I can rewrite that as the absolute value of 2 times x plus 2 minus 8 is less than epsilon. But 2 times x plus 2, that's just f of x. So this is the absolute value of f of x minus 8 is less than epsilon. And 2 times x plus 2 isn't really f of x, but as long as x isn't equal to 2, which in this case it is not because 0 is less than x minus 2, then it is the same thing. So I'm getting the absolute value of f of x minus 8 is less than epsilon. But that's exactly what we needed to show that the limit as x approaches 2 of f of x is equal to 8. So no matter what epsilon you pick, if you just cut that in half for this particular function, if you just cut that epsilon in half, that delta will give you a value that works. And so our limit as x approaches 2 of f of x, but f of x is 2x squared minus 8 over x minus 2 is equal to 8. And that is the proof.